Namaskar, dear learners. I, Dr. Shweta Tripathi, Assistant Professor from School of Engineering and Technology, welcome you for this session on Energy Management, MRW 004. Today we are going to cover the topic Energy Conservation. What is energy management? When we talk about this course, you already have completed the courses like energy conversion and energy and environment. So you know about energy, its form and its conversion and various techniques by which it is converted from one form to another. So now we are taking this course energy management, and what we have to understand in this course is that how we are going to utilize energy efficiently, and this is known as energy management. In this course we have 4 blocks. First block is about energy management, second block is about thermal energy management, third block is about electrical energy management, and the last block is about the general case studies of various energy conservation measures that we can utilize, how they are helpful for us. So in the very first block, that is energy management, we have to discuss about energy conservation, energy audit, how it takes place. So if we want to manage energy, what we have to do, we have to account that where we are using energy smartly and where the losses are more. If the losses are more, we have to reduce those losses, and thus we can say that we are managing the energy very well, and this process is known as energy management. So 2 things we have to focus in energy management. One is to utilize the best source of energy or the most feasible source of energy, and another thing that is there is to utilize it very efficiently so that the losses should be less. So 2 things are there. First is about the resources, that is resource management, and another thing is to utilize it very efficiently. So these are the 2 things that we have to focus when we talk about energy management. So there are various resources of energy that are already available and you all know about them. Then how we can efficiently utilize them, and what is energy conservation, what is energy audit, that we are going to discuss here. Suppose you want to conserve energy or you want to manage energy. First thing that will come to your picture is that how much energy do you have? That is the input energy or the energy that is available with you. Second thing that you need to know is that how much energy you are going to use from that particular available energy. So if you have available energy and you are utilizing it for any end use, some losses are in between and you have to minimize these losses. So it is but obvious that you have to make an account of how much energy is available, how much losses are there, and how you can minimize these losses, and how much energy you are getting at the end or you are utilizing. So the accounting of all these things are known as energy audit, and this help us in energy management or energy conservation. So in today's lecture, we are going to discuss about this. We all know that energy is the basic requirement for economic development of any nation. Okay, every country needs some amount of energy, or we can say adequate amount of energy for each and every sector. If we see about this energy consumption sector wise, we utilize maximum energy in industrial sector. We utilize energy for the transportation as well. We utilize it for our domestic purposes, that is in our residences, and some of the energy is utilized in the commercial sectors as well. Now this is the data of 2012, and there is no doubt that with increasing years, or as the years are going going forward, the energy consumption is increasing in each and every field. If you check the data of your home, that the energy that you were utilizing in 2010, 2012 or even in 2015 and the energy that you are utilizing in 23, there is a difference and you are utilizing more energy. Why? Because we are utilizing more equipments. If I talk about myself, in the year 2005 or 6, we were using very less air conditions and all. And now in each and every home we have air conditions, we have refrigerators, and all these equipment need electrical energy. So our domestic energy consumption is also increasing day by day. And for the industries and all, also the energy consumption is increasing. But the resources that we were using earlier, for example, if I talk about 2005-6, we were utilizing coal, oil only. Now also we are utilizing coal and oil, but beside it we have substituted these energy resources with solar energy, etc. also. So as the energy consumption is, need of energy is increasing, demand of energy is increasing, our day-to-day activities are mostly based upon the energy. So now energy consumption is increasing, our demand is increasing, but supply is not adequate. So for that we have to make a balance, and that is also the energy management. Now, as you all know that we have learned that energy is conserved only. First law of thermodynamics says, that is law of energy conservation. It says that energy is neither created nor destroyed, it can only be converted from one form to another. And why we are converting it from one form to another? Because the energy that is available in the nature and the energy that we want to use for any specific purpose have different forms. So we have to convert it. For example, we have fuel, and in fuel, every fuel has chemical energy. And we need heat energy or we need electrical energy. Then what we do? We convert this chemical energy into heat, and then we utilize this heat energy or directly, or we can convert this heat energy again into the mechanical energy or electrical energy, depending upon the usage. For example, if we want to go for the transportation sector, this fuel is converted into the chemical energy of the fuel is converted into heat energy, and this heat energy is utilized for the mechanical purposes and is converted into the mechanical energy. If we want to generate electricity, what we do? We utilize the chemical energy of this fuel to produce heat, and then this heat energy is used to in the boiler, okay, to produce steam, and then this steam is used to drive turbine, that is again a mechanical energy, and then this rotatory motion of the turbine is used to produce electricity by the generator. So this is how we are going to convert the energy into the useful form, or the form in which we need it to utilize for our day-to-day need or the end purpose. So if we want to convert the energy, there are some losses. Okay, heat is not created, energy is not created, it is not generated, but still when we are transforming it or converting it from one form to another, there are several losses. And when we want to conserve energy or when we want to manage this energy, we want to minimize the loss. And if we are able to minimize the losses, then it could be said that the usage of energy is efficient. So for this, we have to learn that how the energy consumption is growing, why the energy consumption is growing, and how we are going to minimize the losses. For this, we have to develop the technologies which are more efficient, which minimize the losses, and then those technology will be used for the energy conservation. Now comes the point that why we are earlier also we were fulfilling our need by the coal and oil, but why we are not going to utilize these things now also? We can utilize this, we are utilizing these things, but what will happen? They are non-renewable energy resources, and the time will come when they will be depleted. And another thing with these fossil fuels or petroleums are that they are not environmental friendly. Lot of pollution is there due to application of these coals, oils, etc. So for the fossil fuel depletion and environmental degradation, both of these things lead to energy substitution. And when we talk about energy conservation, what we can do to save these reserves of coal or oil or our conventional energy resources which are non-renewable, we can do two things. Either we will go for energy substitution or we will go for energy conservation. Energy substitution means we will substitute these energy resources by the renewable energy resource. We can go for hydro energy, we can go for biomass, we can go for solar energy, wind energy, geothermal energy. Lot of new and renewable energy resources are there. Another thing, that is conservation of energy. And what does it mean? It means to save the energy. We are not going to use excess energy. Okay. We have to utilize the energy efficiently. How? Either by switching to the technologies which are more efficient. Suppose you want to utilize electrical energy in your home and you are using refrigerators, etc. Then what you can do? You can switch for the star rating equipments which take minimum energies. Similarly, if you are not in the room, you can switch off the light and all. So that is also an efficient use of energy. So this is how we are going to conserve energy. Now, as we know that there is a gap between demand and supply, and why this is there? Because specific energy consumption per unit of production is increasing. And why this specific energy we are talking about specific energy consumption? Because when we are producing anything, for example, if we talk about cement industry or steel industry, then per ton production of steel will take more amount of energy rather than per ton specific energy consumption of cement, and likewise other things are also there. So why this specific energy consumption? Specific energy consumption means it will be for a particular weight. For example, here we are talking about specific energy consumption per ton. So how much energy we are utilizing for the production of each and every element. For example, iron and steel, we need more specific energy consumption. For cement and fertilizers, we need less energy consumption. So this is how we are going to, and this energy consumption is increasing. Why? Because our need for this iron and steel or cement is increasing. Why? Maybe one of the reason is the population is increasing and we are utilizing these things more. Then what is the solution? If the energy demand gap is there, what could be the solution for this? We understand that there is an energy crisis. So the solution that we have told is already there. Two solutions are there, and that will be from the energy management only. The first one is either we have to substitute the energy resource that is available with us, or we have to conserve the energy. Now, if we talk about energy conservation, it assures the optimum use of whatever available energy is with us or whatever available resource is with us. For example, if we talk about fuel, every fuel has different calorific value. What is calorific value? If we burn 1 kg of a fuel, how much energy we are getting? It is the calorific value of a fuel. If we directly burn the wood, the calorific value will be different. And if we will do combustion or pyrolysis process of this wood and then we will get a gas, then the calorific value of that gas will be different. So direct combustion and indirect combustion, both are there. Then we have to use the optimum fuel. Optimum fuel means the fuel that is having better calorific value. We have to convert this wood or the woody biomass or the leaves, etc., or the oil that is available with us, we have to convert these solid fuels into either liquid or into the gaseous forms. What will happen if we convert liquid fuels have better combustion properties and gas fuels have more better combustion property. So gaseous fuels are best. So we have to develop the conversion processes or techniques which will convert these biomass that are available with us into the liquid or gaseous fuels, and then we will utilize it for the combustion process. So this is one method how we are going to increase the energy content. Then when we are substituting our technique or substituting the fuel, we can substitute whole technology also. Suppose we are taking the power from thermal power plant and we want to conserve energy, then we can switch towards the solar energy also. When we will utilize the energy from the solar, we can conserve particular amount of the coal or oil that we were using earlier. But how we will follow that, whether we have to use solar energy or we have to use, so some techno-economic analysis is there, and when we do this techno-economic analysis, we have to know all about the technology and the economics that is behind these resources or technologies. So two things are there, either energy conservation or energy substitution. Energy conservation, I mean by energy conservation, saving of energy. We can use efficient process, we do not waste energy, we can minimize the losses, and these all things I count on energy conservation. And energy substitution, I am conserving energy by changing the technology that is available with me. So if we talk about the energy substitution, India is blessed with variety of renewable energy. We have sources like wind energy, solar energy, we have hydropower also, we have biomass also. So depending upon the region, we may choose the energy resource. For example, if we talk about the Rajasthan and all, lot of solar energy is available. If we talk about the coastal areas, there we have sun also, and wind energy is also there. Then we can go for the hybrid technologies where wind farms are also there and solar energy is also there. Suppose if we talk about Uttarakhand and all, there are a lot of rivers and there we can utilize the hydropower. Similarly, biomass is available. India is an agricultural country and lot of biomass is available here and there, and we can utilize this biomass for the generation of energy. Generally in the ancient time or now also in the villages, people used to direct combustion of wood or cow dungs, etc., for the production of energy, for cooking their foods or heating water and all. So I am not saying that direct combustion should not be there, but in direct combustion there is lot of energy is wasted there, and the pollution is also more. So if we can convert this biomass into biogas or we can convert it into the biofuel, then we can utilize most of it and the losses will be lower there. The next thing is we can utilize the opportunities of energy conservation wherever it is available. Suppose lot of electrical energy could be saved if we can change our bulbs or tube lights that we were using earlier by CFL. And nowadays it has become a common practice, and now in every houses we can see the CFLs, even LEDs, etc. Whereas once upon the time, in each and every house's fluorescent bulbs were there. So likewise this, you can utilize the power factor improvement equipments as well for saving the energy. You can utilize the equipments which have better energy saving system. For example, a star rating is there which tells us that which equipment will conserve more energy. So we can go for those equipments as well. So if we talk about these two approaches for achieving, then we can utilize energy efficient devices like CFL, etc., efficient motors, etc., and we can adopt good housekeeping measures as well. What will happen in good housekeeping measures? In which it is quite obvious that when we are not in the room, we will not leave the fan and lights switched on. We will utilize the gas, etc. When we are utilizing the energy for the cooking purposes, we have to do certain things. Suppose we can cook mostly things in the pressure cookers, it will take lesser energy. We can soak the things like rice, pulses, etc. before cooking. So why all these things? To conserve the energy. So there are a lot of housekeeping measures also which will help us to conserve the energy. Then in the similar fashion, if we go into the industry, there are also the various things to conserve energy, various measures we can adopt for the energy conservation. And as we were discussing about the techno-economics, when we go for the energy conservation in the industry, then we have to identify all these things into three categories: short-term measures, medium-term measures, and long-term measures. Short-term measures means like changing the bulbs, CFLs, etc., for which we will get the payback period within a month. For medium-term measures, this payback period will be few months, and for the long-term measures, it will be for the years. Suppose I want to change the energy that I am getting from the powerhouses and all. I am going to switch towards the solar energy, and I want to get it done. Then what will happen? It will be in the long-term measure because my payback period will be more. Why? Because the capital cost is more here. Similarly, this is that we are adopting a new technology. Another thing is that at every point I have to save some energy. Suppose if I talk about paper and pulp industry, then wherever the production unit is there, how much heat is there, how much heat is wasted. So I can take an account that if I am able to utilize the waste heat that is going outside for reheating purpose or something else, then that is also the conservation of energy. So if we talk about industries, there are various methods by which we can conserve the energy at each and every step. We can move towards the more efficient technology also, and we can adopt some measures by which the losses will be low. And to account these losses and all, we make a Sankey diagram there. Okay, now I emphasize more on the energy conservation rather than substitution of the energy. Why? Because if I am going to save 100 units of electricity, so I find it better than generating 100 units in a power plant, because when I am generating the power, there are certain losses there. Okay, distribution loss is there, transmission loss is there. So if I am saving 100 unit, it means I am conserving 100 unit here. It means I am generating more units. Why? Because the losses are not there. And then whenever the energy is produced or generated, many pollution pollution is there. So if I am using less energy or using energy efficiently, it means that I am helping in reducing the pollution. I am reducing in the terms of thermal pollution. I am less responsible for the global warming also. So if we have a choice between the conservation and substitution, so my choice will be always for the energy conservation, because generally it take lot of time to generate the energy, lot of resources are there, and then at the same time the transmission and distribution losses are also there. Moreover, we can apply these conservation measures quickly. If I want to increase the capacity of any power plant or capacity of energy production, then it will take 5 to 7 years to build a similar kind of power plant, or to identify the resource, utilize the resource. It will take time. But when I am going for the conservation measure, I can start it from now onward. So these are the things which we have to keep in our mind. Then comes the why conservation of fossil fuels is more important, because we can use it as a raw material in some other industries also, in addition to their use as fuels in the power generation. So wherever we can switch from these fossil fuels or the non-renewable energy resources, we have to switch forward. Then every human being can save energy, and he or she can adopt energy conservation measures wherever he is. So wherever there is energy production or energy generation, there is always a scope of energy conservation as well. So this was all about the energy conservation. In our next session, we will be discussing about the energy conservation measures that we can adopt in various sectors like industries, transportation, etc. Thank you very much.